Welcome to another episode of CSEC Maths with Sir Kumar. In our last episode, we looked at the area of simple plane figures. In today's episode, we will be focusing on the circle. Before we get into the lesson, let me first define what is a circle. A circle is a curved closed figure that's formed by points that are of equal distance from the center. Now, if you look here, we have a circle here. Now this is what we call the center, and if you notice, if I'm to draw points around this circle, then each point would be the same distance away from this center. So when you have all the points going around and you connect the dots or you connect the points, it forms a circle. So the first thing we're going to look at would be the parts of a circle. Then we're going to go into the circumference of a circle, the area of a circle, and then we're going to focus on one part of the circle, which is the sector. We're going to find the length of the arc, and we're going to find the area of that sector. So the first thing we're going to be looking at would be the parts of a circle. Let's get into it. The first one we have here is the diameter. The diameter is a straight line segment which passes through the center of the circle, and the endpoints touches the circumference of the circle. If you look at our diagram, this is what we call the center. So the line that goes from one point on the circumference to the other point of the circumference and passes through the center is called the diameter. Remember, it must pass through the center to be called the diameter. The second one is radius. The radius is a straight line segment which joins the center of the circle to any point on the circumference of the circle. So the radius goes from the center to any point on this circumference or the outer part of the circle. So any point coming from this center to any point on this circle, we call it the radius. And if you notice, the radius is basically half of my diameter, right? So from the center to the circumference is the radius, and the diameter is from circumference to circumference and passing through the center. The third one is the chord. So the chord is a straight line segment which does not pass through the center of the circle and whose endpoints touch the circumference of the circle. Now, this is what we call the center of the circle, right? So any line that passes from that goes from circumference to circumference and does not go through the center is what we call the chord. So if we have this line as close as possible to our center, as long as it doesn't touch the center or passes through the center, it's considered a chord. The fourth one we have is the sector. The sector is a portion of a circle which is defined by two radii and an arc. Now, one of these lines, we call them a radius. So when you have two of them, the plural, it's radii. So the portion between two radii and the arc, so the two radii and the arc is what we call a sector. Now when dealing with sectors, you have two of them. You have this part, which we call the minor sector, and then the remainder of the circle is what we call the major sector. So remember, there is a minor sector and there is a major sector. And when you think of sectors, you could remember the pizza. The sector is like a pizza, a slice of the pizza that you're going to get. So the minor one is the little one and the major one is the rest of the circle. Segment. The segment is a portion of a circle which is defined by a chord and an arc. Again, we looked at chord earlier. This is the chord, and this part of the circumference is what we call the arc. So the segment is this portion here. So when we look at segments, we have two of them as well. We have a minor segment and we have a major segment. So this part is what we call the minor segment, and the rest of the circle is what we would call our major segment, right? So this is the small part, and the rest of the circle is what we call the major segment. And the last one we have here is the circumference of a circle. The circumference is the distance around the outside of a circle. So when you're asked to find the circumference, it's this entire distance here that goes around the circle. So in the next part of this lesson, we will be looking at calculating the circumference of the circle, which is the distance outside of the circle. There is a new term that was introduced to you, and that's the arc. So remember I said that the arc is a part of our circumference. It's not the entire thing, it's a part of our circumference. The first thing we'll be looking at is the circumference of a circle. Remember earlier we said that the circumference is the distance around the outside of the circle. So now we're going to calculate the distance, the actual distance around given circles. So when we're dealing with circles, there is this symbol, which is a Greek letter, and it's pronounced pi. So pi, usually the value of pi is 22/7, or approximately 3.142. When your teacher or your examiner is given these questions, they would say use 22/7 or use 3.142. But in cases where you aren't given the choice, they didn't say what to use, we always stick with its original value, which is 22/7, because this is just an approximation. So if they say to use 22/7 or 3.142, then we use that. But if they didn't give you anything to use, then we stick with 22/7. So when finding the circumference of a circle, you have two scenarios. The first one is the formula is C is equals to pi d, where d is the diameter. And the second one is C is equals to 2 pi r, where r is the radius. And if you look here, when you are given the diameter, which is the length from circumference to circumference passing through the center, we use this formula. And when you are given the radius, which is from center to the circumference, we use this formula. Now, we're going to go to two examples, and I'm going to give you an application of both of them so you get an idea of how to use them. So in our first question, we have a circle with 8 centimeters. And look at it, it's a line coming from one circumference to the other circumference, passing through the center. Then this is our diameter. So once you identify that this is the diameter, then we go to our diameter formula, which is C is equals to pi d. So the formula that we're going to use is C is equals to pi d. C is equals to pi. Remember, pi is 22/7. So we put in the value of pi. And remember, when you don't have a sign between here, we have to multiply. So it's 22/7 multiplied by d, which is our diameter. And the diameter is 8 cm. Now, when you have a single whole, you have a fraction here and you have a single whole number. We have to make this into a fraction. And when you have whole numbers, to make them into a fraction, you simply put them over 1. So all you do is you put a line and you make the denominator 1. So now we have two fractions and we're multiplying fractions. So C is equals to, we multiply our numerators, which is 22 times 8, and that's going to give me 176 cm. Divided by 7 times 1, that's going to give me 7. Circumference is equal to, we divide 176 by 7, and that's going to give me 25.14 centimeters. So the distance around a circle with a diameter of 8 centimeters would be 25.14 cm. Now, let's look at our second example. In this one, our line given is from the center to the circumference. So you know right away this is our radius. And since this is our radius, we have to go to our radius formula, right? So our radius formula is C is equals to 2 pi r. C is equals to 2. Again, no sign in between means we multiply. We know that pi is 22/7, and r is given as 5 cm. Make our whole numbers into fractions. We put them over 1. And then we multiply our numerators. That would be 2 multiplied by 22 multiplied by 5. And that's going to give me 220 centimeters divided by 1 times 7 times 1 is going to give me 7. C is equals to 220 divided by 7 would give me 31.42 centimeters. And this is the distance around a circle with a radius of 5 centimeters. So when you're working circumference of a circle, remember you have to look for what is given. If it's the diameter, you use the pi d formula, and if it's the radius, you use the 2 pi r formula. Now we're going to be looking at how we calculate the area of a circle. And if you could remember from our previous episode, we said that the area is the measure of surface. So when we're calculating the area of a circle, it's actually the size of this surface here, right? Now, again, remember that when we're dealing with circles, we use pi. Pi is 22 over 7, or 3.142. And the formula to find the area of a circle is A is equals to pi r squared, where r is the radius. And this is an example of what the radius would be like. Now, what happens if they don't give us a radius and they give us a diameter? Now you have to go and find what is that radius, right? So in the case of given a diameter, which is the length straight across, we say that r is equals to d divided by 2, which is the diameter divided by 2, right? So let me just add this here, where d is the diameter. So whatever length is given as the diameter, we just divide it by 2 and we would find what is the radius. Now let's look at some questions with the application of the formula. So you have 2 examples here. The first one, so the general heading is calculate the area of the following. In this one, we have 4 cm, and since it's from the center to the circumference, we know that this is our radius. So A is equals to pi r squared. A is equals to, we know that pi is 22 over 7, and no signs, so we multiply. R squared, that means r multiplied by itself 2 times. So that's going to be 4 multiplied by 4. Make them into fractions, we put them over 1. Then we multiply our numerators. That's going to be 22 multiplied by 4 multiplied by 4. And that's going to give me 352 divided by 7 times 1 times 1 is going to give me 7. When we divide the 2, 352 divided by 7, we're going to get 50.29. And we're working in cm. And remember we said that yesterday, once we were finding area, our unit is in squared, right? So this would be cm squared. So this is the area of a circle with radius 4 centimeters. Now let's look at this example. If you notice here, we have 16 cm, but this is not the radius they gave us here. They gave us the diameter. So before we start working this question, we have to go and find the radius. And we said that the radius is to find the radius, it's the diameter divided by 2. So r is equals to d divided by 2. The diameter is 16, so 16 cm divided by 2 is going to give me 8 cm. So my radius is now 8 centimeters. Now using r, we substitute into our formula for area. A is equals to pi r squared. A is equals to pi is 22 over 7 multiplied by r 2 times. So r is 8. So it's going to be 8 multiplied by 8. We put them over 1 and then we start to simplify. So 22 times 8 is going to give me 1,408 divided by 7 times 1 times 1 is going to give me 7. 1,408 divided by 7 is going to give me 201.14. We're working in centimeters and it's cm squared. So the area of a circle with diameter 16 cm is 201.14 cm. What you should remember is that if you're not given the radius, you have to divide the diameter by 2 to find the radius. And if you are given the radius, you go straight into the question and you use your formula and you substitute the values given. We've just completed the circumference of a circle and the area of a circle. Now, we worked questions where they just gave you a circle and measurements and we moved from there. Now, what happens if they give you a question in words that you have to read and then draw? So let's look at two of these. So it's going to be both circumference and area. So the first one is, a dog is tied to a wooden stake in a backyard. His leash is 3 meters long and he runs around in circles pulling the leash as far as it can go. How much area does the dog have to run around? Now, first thing you have to remember is that you have a stake in the ground. So let's call the stake the center of the circle. You have the leash, and what does a dog look like? Let's draw two circles, or a circle and an oval. So you have a dog. So let me erase this. So the stake is here, the leash, and then the dog. So all that's happening is that this dog could go around in a circle, right? And the length of his leash is 3 meters. Now, the stake becomes the center of our circle. The leash is our radius, and then the circle that he's making would be the circumference. Well, we don't want the circumference, we want the area. So looking at this little thing, let's just take out the circle and work with it. So we have our circle with 3 meters. And we said that this is our radius. Area for a circle, the formula is A is equals to pi r squared. A is equals to pi, which is 22 over 7, multiplied by our radius, which is 3 times 3. We put them over 1. A equals, and then we multiply our numerators, which is going to be 22 times 3 times 3. And that's going to give me 198 divided by 7 times 1 times 1 is 7. Dividing the 2, our area is going to be 28.29. We're working with meters, so my unit is meters square. And this is the area that the dog has when the leash is at full length and he's going around in a circle. Let's look at the second worded question. So you have here the radius of the wheel of a truck is 1.5 meters. What is the circumference of the wheel? Well, everybody know what a wheel looks like, right? So you have a wheel of a truck. Nuts. So they're saying that the radius, which is from the center part that's in here to the end of this wheel, is 1.5 meters. They want to know what is the circumference of this wheel, which would be the size of the wheel around it, right? So let's take out our little circle and work with this. So they gave you the radius as 1.5 meters and they want you to find the circumference. Now remember, there are two formulas when finding the circumference. So in this case, since we have the radius, we have to use the radius formula. And the radius formula to find the circumference is C is equals to 2 pi r. That's going to be C is equals to 2 pi is 22 over 7 and r is 1.5. Make them into fractions. We put them over 1. So C is going to be equals to 2 times 22 times 1.5 is going to give me 66 divided by 7. 66 divided by 7 is going to give me 9.43 meters. We don't have meters squared, right? Because we're looking at circumference. So the distance around this wheel, or the size of this wheel, is 9.42 meters. So we've looked at the circumference of a circle and we've looked at the area of a circle. Now let's go down to the specific part of the circle. So we're going to look at the length of an arc. And An arc is a portion of the circumference of the circle. If you could remember, I did mention that in the first part where I was going through the parts of a circle. So if you look here, the parts that I mark off with these two lines, and this upper part here is an arc. So this is just a portion of the circumference, not the entire thing. Now, when you're looking at arc, you have what we call the minor arc, and then the rest of the circle becomes the major arc. When you're given questions and they say, find the length of an arc, then it's the minor arc you're finding, unless the examiner says, find the length of the major arc. Then you would have to go and find the rest of the circle. But if they say find the length of an arc alone, we're working with our minor arc, right? So the formula to find the length of an arc is L is equals to 2 pi r theta over 360, where r is the radius and theta is the angle given. And if you look here, in most of the questions that you're going to find with length of an arc, they're going to give you from a sector. So when they give you the sector, you have the two radii, and then you have the angle given in the middle. So the length of the arc that they want you to find would be the length of this portion here. So again, remember the sector is like a pizza. So just imagine you taking out a slice of the pizza. They just want you to find the length of this curve up here, the curved end. So let's look at an example of how we would find the length of this arc. Now we have a question here. You have a circle. The radius is 5 centimeters and they give you the angle as 60 degrees. Now let's use the formula and substitute our value. So we have theta equals to 60 degrees and we have r is equals to 5 centimeters. Our formula is L is equals to 2 pi r theta over 360. Remember, no signs again, so it's all multiplication. So let's start substituting. So L is equals to 2 multiplied by pi, which is 22 over 7 multiplied by r, which is given as 5, multiplied by theta, which is 60 over 360. Make our whole numbers into fractions, we put them over 1. L is equal to, we multiply all our numerators. That would be 2 times 22 times 5 times 60, and that's going to give me 79,200. Divided by 1 times 7 times 1 times 360. It's actually 7 times 360 because the ones would give us the same thing. 7 times 360 is going to give me 2,520. Dividing 79,200 by 2,520, we would get 31.43. And we're working with length, so this is in, and we're working with cm, so this is centimeters. So the length of this little portion here is 31.43 cm. Now what you can do at home is, using the same information that you have here on this circle, go and find the length of the major arc. We know that this portion is 60 degrees, then you have to get the angle around here. So if this is 60, the entire rotation of a circle is 360. Now the angle you would be working with would be 300 degrees. So using 300 degrees and the radius is as 5, you can go and find the length of the major the major arc of this circle. We're now going to look at the area of a sector. Just a quick reminder, what's a sector? A sector is a portion of the circle as defined by two radii and an arc. Now, when we're looking at sectors, again, we have a minor sector and we have a major sector. So let's say this is the pizza that you bought from Pizza Hut. So when you take out one slice, that becomes the minor sector, and the rest of the pizza that remains is what we call the major sector. Now the formula to calculate the area of a sector is A is equals to pi r squared theta over 360, where r is the radius and theta is the angle of the sector. Now, let's use this formula in the question that we have over here. So calculate the area of the sector. In this case again, when they say calculate the area of the sector, we're finding the area of our minor sector, right? So let's see what we're given. So 4.5 is r, so that's our radius. The angle given is theta, so theta is equals to 60 degrees. And our formula is A is equals to pi r square theta over 360. Now let's substitute our values into this formula and find the area of this sector. So A is equals to pi, which is 22 over 7 multiplied by the radius squared. That means the radius 2 times. So that's going to be 4.5 multiplied by 4.5 multiplied by theta, which is 60 over 360. Make these two into fractions, we put them over 1. Then we go to multiplying all our numerators. That's going to be 22 times 4.5 times 4.5 times 60, and that's going to give me 26,730 divided by 7 times 1 times 1 times 360, which is 7 times 360. That's going to give me 2,520. Divide the 2, we have our area is equals to 10.61. We're working with meters, so my unit is meters, and since we're finding area, it is meters square. So this is the area of this little piece. What you could do at home is find the area of the major sector. That would be the area of all of this that's remaining. So you have to now go and find what is the angle around here. Remember again, it's 360. They gave you 60, so this piece would be 300. So now to find for the major sector, your theta is going to be 300 degrees. And you go and find the area of the major sector. So let's conclude today's lesson. Today's lesson we looked at circles, and we did 4 things with circles, and they're listed here. First, we found the circumference, then we found the area, we found the length of an arc, and then we found the area of a sector. What you have to do is to remember your formulas when working. The circumference and the length of an arc formula is a bit similar with the addition of the theta over 360, and likewise the area and the area of a sector formula is similar with the addition of the theta over 360. Remember that pi is always 22 over 7, or if they say to use it as 3.142, you do that, or you use it as 22 over 7. When you're finding the length of an arc, it's always the minor arc unless they ask you to find the major arc. Same goes for the sector of a circle.